Hey everyone, so we're going to talk about how to pass the PERT, the math section. And so there's about 30 questions and there's no time limit, but it is a computer adaptive test. So that means that the better you do on the questions, the harder they get or the easier they get. And then once it collects enough data, it'll move you on to the next section. So I'm going to break this up into three separate parts. So there's pre-algebra, algebra, and geometry and data analysis. So we're going to start with pre-algebra, which will be about 20 to 25% of the test. So the first thing that you're going to see is integer operations, decimal operations, and fraction operations. And I'm not going to cover that on this video, but do keep in mind that you'll have to do all of these questions without a calculator. So the first thing we're going to talk about is calculating percentages and going between percentages, fractions, and decimals. So first, we can look here, and we can see that 50%, if you were to visualize that, it would look like this. So we know that 50% is half, and 50% expressed in a fraction is 50/100ths. So simplifying that, we would get 0.5, because when you divide by fractions, you move the decimal forward by the number of zeros. But if we were to look at 28%, dividing that by 100, our decimal would be 0.28. But then visualizing this, we have our 28%, but we wouldn't say 28/100ths. We would want to simplify that fraction. And when I simplify fractions, I usually start with if both the two ending numbers can be divided by 2. If not, then I go to 3, then 5, 7. And if both ending numbers can't be divided by any of those numbers, you're probably done reducing your fraction. So like here, 7 and 5 can't be reduced by, or can't be divided by 2, 3, 5, or 7. When we want to find percents by tens, we think, so we have 10 divided by 100 is 10%, right? So then our decimal of that would be 0.1. So when we're trying to find 10% of a number, we have 1182. We'll move our decimal place over 1 because we'll be multiplying this by 0.1. So that's the same number, you just add your decimal. So that's 10%. But what if we want 20%? We'll move the decimal over the same and then just multiply the whole number by 2, which equals this number right here. Because, again, you'll have 1182 times 0.2. So that's 4, 16, 3, 2. And then you'll add your decimal. Next, if we want to find the percentage of a number, but it's not by tens, we, again, just multiply. So we have 1182 times 0.28. And then multiplying this out, we get 330.96, and we add our decimal, which is 2 places because we have 2 places here. So we want to remember that a percentage is a part divided by whole times 100. If we're dividing by a power of 10, we move the decimal forward, making it smaller. So 28 divided by 10 equals 2.8, corresponding to the number of zeros. And if we're multiplying by 10, we move the decimal back, making it larger. So our decimal's here, we're going to move it that way. Okay, so let's go into some practice problems. So the questions on the PERT can get kind of confusing because it's not only calculating percentages. So first we'll do what percentage of 200 is 50. So we're looking for the percentage. of 200 is 50. So reducing this, we've got, and then dividing by 5, we've got 1/4 times 100, which is 0.25 times 100 equals 25%. Next, 30% of a number is 90. What's the number? So we'll start with 30% on this side. And we don't have to use, so we have part over whole times 100 equals the percentage. Since we already have the percentage here, we don't need to worry about multiplying by 100 because this is not a decimal. So we'll just have part over whole. So our part is 90 because 30% of a number is 90. So we're looking for this number. The first thing that we'll do is convert this to a decimal. We'll have 90 over x equals 0.30. Then we have 90 over, or whoops. Then we have 90 equals 0.3x divided by 0.3. So then we have x equals 90 divided by 0.3. And I don't like to divide by decimals. So instead, I'm going to say 90 times, because we'll have 0.3 is equal to 30 over 100. So then we take 90 times 100 over 30, because we flip the fraction to multiply. So now I'm going to reduce this, take out those, and then we'll take out this. So that's 3. So x is 300. And to check this, we can say, so 90 over 300 times 100. We'll reduce this. So that would be 3 over 10. Yeah, so that's 0.3 times 100 because we have 10 down here. So we just, and that's gone, the zero's gone. So we'll move our decimal that way, which equals 30%. Next, a price was $80 and now it's 100. What is the percentage increase? So first we can find $100 minus $80 equals $20. So that's how much the price increased. But we want to know what is the percentage increase. So we'll do 20 over 80, that's the original price, times 100. Cancel those out. You have 1/4. So then that's 0.25 times 100 is 25%. And again, to check this, we can go back and find 25% of $80, which we'll do like this, times 0.25. 0, that's 40. 0, 0, 16. Add our decimal, and that is 20, which is our dollar amount increase. Last, if you invest $200 at an interest rate of 5% per year, how much will you have in 3 years? I'll zoom out a little bit. So we start with $200, and it accrues an interest of 5% per year. And we want to know how much will you have in 3 years. So first, let's start by finding 5% of 200. which is 0.05. And then we don't need to multiply these zeros because it'll just be more zeros. And we'll add our decimal place for 2 places. So that's $10 per year plus 3 years equals, or times 3 years equals $30 in 3 years. But it does want to know how much will we have total. So we're going to add this. Oops. Plus 30. So we'll have $230 in 3 years. Next, we can talk about proportions and ratios. So a proportion is a comparison of two quantities that shows how many times one quantity is related to the other. And we express it A to B or A over B or A to B. It's a part to whole or a part to part ratio. How much there is of one thing compared to another thing. And there's no units. So for example, we have 2 to 3. For every 2 apples, there are 3 oranges, or 4 out of 5. So 4 out of 5 students prefer chocolate ice cream. And a non-example is dividing the fraction, because this is not a number. Next, we have a proportion. So a proportion is an equation that shows 2 ratios are equivalent. 2 ratios which represent the same relationship by 2 quantities. So we can look at it as A over B equals C over D, A to B equals C to D, and it's useful for scaling, resizing, or comparing. And we utilize cross multiplication usually to solve these types of problems. So for example, if 5 apples cost $2, how much will 15 cost? So we set it up as 5 apples cost $2, and then we have 15 apples. It'll correspond this way. And we're looking for how much that would cost, right? So then cross multiplying, we have $30 equals 5 times X. And simplifying that, our X would be $6. So for 15 apples, it would cost $6. If a recipe calls for 2 cups of flour for 4 servings, how much is needed for 10 servings? So again, we have 2 cups for 4 servings, and then we line up our servings because we're looking for 10, and we're looking for how many cups of flour we would need for those 10 servings. So cross multiplying, we have 20 equals 4 times X. And simplifying that, we get 5 cups. So for 10 servings, we need 5 cups of flour. And a non-example is this. So 3 and 4 and 5 and 6. So these, if we put them in fraction form, they're not equivalent. They're ratios, but they're not proportions because they are not equivalent. Okay, so we want to recognize when a question is asking about a proportion or ratio instead of an equation or geometry. And that'll be clear once we get to our examples. We want to utilize cross multiplication, and we want to set up a problem in the way that guarantees an equivalent proportion. So first we have, in a classroom, the ratio of boys to girls is 3 to 4. So we'll write it like this. And we'll say boys to girls, matching them up. But we have 21 boys, and we're looking for the number of girls. So now we'll set up our proportion as 3/4 equals 21 over X. And then cross multiplying, we have 3x equals 84 divided by 3. X equals 28 girls. Next, we have 5 gallons of paint, covers 200 square feet. And we want to know how many square feet 8 gallons of paint will cover. So then we have 8 matching up the paint, and we're looking for how many square feet. So cross multiplying, we've got 1600 equals 5x divided by 5. X equals 320 square feet. The ratio of ages of Alice to Bob is 3 to 5. So we'll write out Alice and Bob. Alice has 3, Bob has 5. So we'll set up our ratio. And Alice is 12. So lining up Alice, we have 12. We want to know how old is Bob. It's cross multiplying. We've got 60 equals 3x. So Bob is 20. Next, we can look at, and last for this portion, or for this part, we're going to look at interpreting word problems into expressions and equations. So our first question is, the sum of Jenny's age and her brother's age is 36 years. Jenny is 6 years older than her brother. How old are each of them? So we'll say that Jenny is 6 years older than her brother. So we're going to make that x plus 6, and then the brother's age will just be represented as x. And the sum of these is equal to 36 years. So if we make this into an equation, it would be 36 equals x plus 6, which equals 2x plus 6 minus 6 minus 6. 30 equals 2x. And then we have x equals 15. So looking back here, we know that x is the brother's age. So the brother is 15. And then we remember that Jenny is 6 years older than her brother. And 15 plus 6 is 21. So Jenny is 21. Next, a movie ticket costs T dollars. If you buy 3 tickets plus a $5 service fee, the total cost is $35. Write an equation to represent this situation and solve for T. So the total cost is $35. And we bought 3 tickets. So that would be 3 times T plus a $5 service fee for all 3 tickets. So our first step is to subtract 5, which means 3T equals 30. Divided by 3. And T equals 10. So each ticket costs $10. Next, Sarah runs 5 miles a day for D days. If she runs a total of 35 miles, how many days has she been running? So we'll start with 35 miles equals 5 times D, because she runs 5 miles each day. So then we'll divide by 5, divide by 5. That means she's been running for 7 days. Last, we've got a chemist is mixing 2 solutions. One is 30% acid and the other is 50% acid. How many liters of each solution should she mix to get 20 liters of a 40% acid solution? So this one is a bit more complex, and we're going to start with what we're looking for. So we want to make 20 liters of a 40% acid solution. And then we've got a 30% acid solution and a 50% acid solution. And we want to assign variables to these two. And what we're looking for is the amount of liters of each solution. So we're going to say that we're going to look for X amount of liters for the 30% acid solution. And we could say Y for the 50% acid solution, but that would make our equation a lot harder to solve. So we want to make a variable for this one in terms of X. So we have 20 liters total is what we're trying to make. So here we could say 20 minus X. We want them to add up to 20. We're going to assign our variables like that. So for one side of our equation, we're going to have 0.30x plus 0.50 times 20 minus x. Because again, we're looking for the number of liters to get this 40% acid solution. And this is our percent acid times the liters, percent acid times the liters. But what goes on this side of the equation? It definitely won't be 20 liters. It's going to be the amount of acid in this many, how many liters of acid it is, basically. So we're trying to make 20 liters of a 40%, oops, of a 40% acid solution. So we're going to say 20 times 0.4 to find out how many liters of acid there are. So there will be 8 liters of acid. And that's what we're going to put on this side of our equation. So we have room. So we'll say 0.30x plus 0.50 20 minus x equals 8. That 0.30x plus multiplying these, (0.50x equals 8. Now we can go ahead and subtract this. -2. And then we'll add these together. That will be -0.2. -0.2x equals -2. Dividing these. So that'll cancel out our negatives. But again, I don't like to divide by decimals. Again, I don't like to divide by decimals. So we've got 2 divided by 0.2. Move our decimal twice. That's going to be 20 over 100. So then we'll say 2 times 100 over 20. And we will cancel these out. That's going to be 10. Cancel that, equals 10. So it actually is 10 liters of each solution. And since this is a pretty complex problem, I like to check my answers. So going back over here, if we have 20 liters of each solution, 50% acid and 30% acid, we should be able to multiply. So we'll have 0.5 times 10 equals 5, and 0.3 times 10 equals 3. Add those together equals 8 liters of acid and 20 liters of a solution.